8.2 is more radicals. It's just, they're getting more complicated. So in 8.1, they were always perfect. So we had like the square root of basically, a number 72 squared, and you just got 72. Or it was a cube root of 27, which was cube root of 3 cubed, and you got 3. So that's kind of what we did in 8.2. Now we're going to have, I guess you could say, leftovers. They're not going to be clean. There's going to be parts that don't come out. So same first step, you prime factorize, and then it's kind of similar second step, pull out all pairs, triples, and quads. I say add the implied 2 when it's a square root. When you pull out the untuples, only one comes out. So that's, remember, like you circle the amount you have and then you pull out one of them. And then the new step here is remember to keep the leftovers, and they're still the nth root of the leftovers. So in this case, 72 square root of 72. 72 is 8 times 9, which is 2 to the third, 3 squared. So I have 3 2's and 2 3's. Since it's a square root, I want pairs. So this pair gets taken out and this pair gets taken out. So I have a 3 times 2 on the outside, but then I have my leftover. So I have my 3 times 2, which is the pulled out, and then I have my square root of what's left, which is the 2. So I have the answer 6 square root of 2. If we're doing with cube roots, again, we have 2, 2, 2, 3, 3. Now I'm dealing with cube roots, so I need triples. So all 3 of these 2's can come out and bring out a 2, but I only have 2 of those, so they have to stay inside. So I'm left with 2 cube root of 3 times 3, which is 2 cube root of 9. And here, in order to get, so I at least have one that was a 4, I times 72 by 2, and I have 2 times 2 to the third, 3 to the half, so that's 2 to the fourth. So I have 4 2's, 2 3's. Since I'm dealing with a fourth root, I'm looking for 4 tuples. So these 2 times 2 times 2 times 2 pulls out just 1 2. These 3's are just sitting there. So I only have 2 of them, and I needed 4's, so they're leftovers. And then I'm left with 2 times the fourth root of 3 times 3, which is 2 times the fourth root of 9. Method 2 would involve converting the nth root to the 1 over nth power and then distribute this power. This is useful. Again, we have to prime factorize the number, convert the radical to the fraction power, distribute the fractional power. Now, the last step is convert the mixed fraction to convert the fractions to mixed numbers. So if we have an n over d, we want some whole number plus c over d. So for example, square root of 32. 32 is 2 to the fifth. So this is 2 to the 5 halves. And then you go 5 halves is 2 plus 1 half. And so this 2 to the 2 plus 1 half becomes 2 to the 2 times 2 to the 1 half. And that is just 2 squared, but 2 to the 1 half is square root of 2. So we have 4 square root of 2. If we look at the third root of 32, so that's 2 to the 5 thirds, because, this would be 2 to the fifth to the 1/3, and then we'd multiply those. 5 thirds is 1 and 2/3. So we'd split this into 2 to the 1 times 2 to the 2/3. And to go back into its radical form, we kind of need to pull out this fraction power, so this is, we have 2 to the 1 times 2 squared to the 1/3. So basically 2/3 is equal to 2 times 1/3, and that's the power I'm pulling out. And then this 1/3 becomes the third root of 2 squared, So we end up with 2 cube root of 4. If we look at 108, cube root of 108, it's 4 times 27, which is 2 squared times 3 to the third. So we have 2 squared, 3 to the third to the 1/3 power, and we get 2 to the 2 times 1/3, which is 2/3, and 3 to the 3 times 1/3, which is 1. So we have 2 to the 2/3 power and 3 to a 1 power. So that's just 3. And then I'm going to convert this 2/3 into 2 squared raised to the 1/3. And so we get this 3 times the cube root of 4. If we compare it to method 1, I can factor out, we have 4, which is 2 times 2, 3 threes. We're dealing with triples. So I'm going to circle my triples, pull them out, and I have my leftover. So I get 3 in the cube root of 2 times 2, which is cube root of 4. So early on, when you don't have that many factors, I think it's easier to use method 1. Later on, it might be easier to use method 2. So for example, in this case, 1028, that is 2 to the 10th power. So I made 10 2's, and I'm doing with the 5th root. So I have to pull out 5 of them and pull out another 5 of them. So I have these two factors of 2, 2 times 2. If I went about it the other way, and I have 5th root of 2 to the 10th equals 2 to the 10th to the 1/5, I can see that this becomes 2 to the 10 over 5, which equals 2 squared, or 4. All right, when you start having fractions, when we're, so either way is challenging here. But if we want to do the method 1 way, which is figuring out, in the case of square roots, pairs. So when I'm dealing with pairs, I need these powers here to be like similar powers. So 17, I can see, is 16 plus 1. And 16 is an even number, so I can write 16 as 8 plus 1, the leftover. So when we're dealing with square roots, the numbers are either going to be 2 times the number plus 1 or 2 times the number plus 0. I mean, that's all numbers are broken, all integers, I should say, are broken into those two categories. And my multiples of 2 are kind of 2, 4, 6, 8, 10, 12. I mean, it's the even numbers. So anytime we have a number, we can either shift it into 2 times the number, like here 6 is 3 plus 3. 27 is odd, so it's 26 plus 1. 26 breaks into 13 plus 13 plus 1. And so what that allows me to do is I can take this number, 144, x to the 17th, y to the 6th over 125, a to the 27th. So the 144 is 12 times 12. The x to the 17th, notice here I have 17 is 8 plus 8 plus 1, so that's x to the 8th, x to the 8th, x to the 1. Y cubed, y to the 6th is just y cubed times y cubed. 125 is 5 times 5 times 5. And then 27 is 13, 13 plus 1. So we have a to the 13th, a to the 13th, a to the 1. So now if I want to do my eliminate, I'm looking for pairs. So I pull out a 12. I have 2x to the 8ths. And I have 2y to the 3rds. And on the bottom, I have 2 5s. And I have 2 of these a to the 13ths. And left over, I have an x to the 1, a 5, and an a. So I have to kind of keep track of my leftovers. So we have fractions. On the top, I have a 12, x to the 8th, y cubed, all over 5a to the 13th. And inside, I'm left with my x, which is the purple, over 5a. What if it's cubed? So if it's cubed, I want groups of 3. So then I'm actually looking for multiples of 3. So a number, these powers, can either be of the form 3n plus 2, 3n plus 1, or 3n plus 0. And so 3n plus 0, those are my multiples of 3, which is 3, 6, 9, 12, 15, 18, 21, 24, 27. And if I wanted to look at what the plus 1 versions, I do 3 plus 1, so that's 4, 6 plus 1, 7, 10, 13, 16, 19, 22, 25, 28, 31. So all the, those numbers would be plus 1. And then if I wanted to do the next set, maybe I'll go to another color gray. So I'd have 5, 8, 11, 14, 17, 20, 23, 26, 29, 32. And what you can sort of see is 3, 4, 5. If I add one more here, this would be plus 3, which is a new multiple of 3. 6, 7, 8, I plus 1, and I'd get to 9. And sort of just keeps sort of repeating itself. But what does that mean I do? So in the case, so I'm looking at my powers of 17, 6, and 27. So 17 is 15 plus 2. And 15 is one of my multiples of 3. And that is 3 times 5. So that means 5 3 times. So I have 5 plus 5 gets us my 15, and then I have my plus 2. 6 is 3 times 2, so that's 2 added to itself 3 times. And 27 is 3 times 9, so 9 added to itself 3 times. So I can now replace 144 was 2 to the 4th, 3 squared. So I do 4 2s, 1, 2, 3, 4, 2 3s, and then I have, this was x to the 17th. So this is x to the 5th, x to the 5th, x to the 5th, x squared. Y to the 6th became y squared, y squared, y squared. 125 is 5 times 5 times 5, and then we have a to the 9th, a to the 9th, a to the 9th. When I go to, I'm looking for triples, 1, 2, 3, so that comes out. 1, nope, 1, 2, nope, 1, 2, 3 of the same thing, so I can pull that out. 1, nope, okay, then we have 1, 2, 3 of the same thing, so I can pull out one of these guys. And down here, I have 1, 2, 3, so I can pull out a 5. And I have 1, 2, 3, and pull out an a to the 9th. So I have my leftover over here and that little x squared. So you got to be careful where your leftovers are. Right big. So on the numerator, we have a 2x to the 5th y squared. In the denominator, we have a 5 a to the 9th. And then inside, we have 2 times 3 times 3, which is 18 x squared over 1. You don't need the over 1, but technically it's there. Doing this again with the 4th root. So with the 4th root, now we're looking at multiples of 4. So, I mean, we've got our multiples of 4, which is 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, and it keeps on going. But if it's a pure multiple of 4, then it's you kind of know what you need to do. But we can also have it be 4 plus 1, 4 plus 2, or 4 plus 3. And, so this would be 5. I want to do gray. 5, 9, 13, 17, 21, 25. And this next would be 6, 10, 14, 18, 22, and this would be 7, 11, 15, 19, 23. Sorry about those. Sorry, I forgot to disable those things. So going to my numbers, 17. My nearest multiple 4 is 16 to 17. So that's 4 times 4. And then we have the plus 1. So it's the second number here. I want to be a different color. It's the second number here that is repeated 4 times. So we have 4 plus 4 plus 4, 4 plus 4 plus the 1. 6 is just 4 plus 2, so that's really 4 times 1. So it's 1 4 times plus the 2. And then 27 is 24 plus 3. So 24 is 4 times 6. So it's 6 added to itself 4 times plus the 3. And I'm highlighting these guys because they're going to be the leftovers. But I now write it all out. 144 is 4 2s and 2 3s. X to the 17th is x to the 4th 4 times and an x to the 1. Y to the 6th is y to the 1 4 times and a y squared. 125 is 5 3 multiplied by itself 3 times. And then a to the 27th is a to the 6th 4 times, and then lastly an a to the 3rd. So now I'm looking for groups of 4. 1, 2, 3, 4. 1, 2, 3, 4 of the same item. 1, 2, 3, 4 of the same item. And then we have 1, 2, let's keep that consistent. 1, 2, 3, 4. And if you're counting 1, 2, 3, can't go any further. So we are left with, we have a 2 x to the 4th, y to the 1, all over a to the 6th. And we're left with this 4th root of, we have 3 times 3, so we have 9 x to the 1 y squared over 125 a cubed. And that's how we sort of go about with that one. With this last one, now we're dealing with a 5th root, so you're looking for multiples of 5. And so when you're looking at the numbers, 17 is 15 plus 2, and 15 is 5 times 3. So we're replacing the 15 with 3 added to itself 5 times. 1, 2, 3, 4, 5. 6 is 5 plus 1, so it's 1 added to itself. 1 plus 2, 3, 4, 5 times, and then we have the remainder of a plus 1. 27 is 25 plus 2. 25 is 5 times 5, so it's 5 added to itself. 1, 2, 3, 4, 5 times, and then the remainder of plus 2. When we start analyzing this, we have, here's our 1, 2, 3, 4, 5 of these x to the 3rds. And we have 1, 2, 3, 4, 5 of these y to the 1s. And we have 1, 2, 3, 4, 5 of these a to the 5ths. And the rest is sort of leftovers. So we have an x cubed y to the 1 all over a to the 5th, and then we have 5th root of, this is the 144 over the 125. Then we have an x squared and the y to the 1, and on the bottom we have an a squared. And that's, that's sort of several examples of reducing. Another thing you can do is if they give you a fraction and you have 16x to the 5th, y to the 7th over 9x cubed, y to the 15th, you can first simplify. You know, in this case, you can simplify first. So I see this is a 3. I'm going to bring it up, and I'll minus 3. Then that cancels out. This 15 is bigger than 7, so I'm going to take the 7 and bring it down. And remember, anytime you move an exponent from down below to above, you're subtracting it, or from above to below, you're still subtracting it to get rid of it. So this simplifies to, I'm gonna write 16 as 4 squared. I have x squared, 5 minus 3 is 2. On the bottom, 9 is 3 squared. And then I have y to the 15 minus 7, which is y to the 8th. Since I now see that I have all even powers, and I know this is a square root, I'm going to shift to my 1/2 power. And I have 4 squared x squared over 3 squared y to the 8th. And I know that I have to distribute this power to all of them, and I get a 4 to the 1, x to the 1 over 3 to the 1, y to the 4th. So we could say this is 4x over 3y to the 4th. If you didn't want to go to the power way, we could have made this square root 4 times 4, x times x, 3 times 3, y to the 4th times y to the 4th, because we did like this is 4 plus 4. And then we could do the whole pull out a 4, pull out an x, pull out a 3, and pull out a y to the 4th.